Okay, I'm going to work through the beginning of section 3.1. And the first thing we talk about is interval notation. And we have here the number line graph of an interval. The first graph shows everything between -1 and 3, including the number 3, but not including the number 1. Both of these number lines show the same set. They just have a different method of notation. We use the second one, the one with the parentheses and the brace. So in both of them, the number 1 has an end that shows that number 1 is not included in the set, and that number 3 is included in the set. We can also write that interval as an inequality, which is -1 is less than x is less than or equal to 3. Or we can write it in interval notation. That's what we always use in this class and pretty much every math class. So we just take, you look at the number line and you just take the ends basically and make them into an interval. Sometimes you have more than one area that you need to express in interval notation, and then we put a U in between them to mean union. Otherwise it looks exactly the same. And those sideways 8s are infinity symbols. And that's it for interval notation. And now on to rationalizing denominators. So we don't like weird things too much in math. In this case, I'm calling the square root a weird thing. We don't like them in the bottom of fractions. We like anything strange to be in the top if we can possibly do that. To get it out of the bottom and into the top, we use something called the conjugate. The conjugate is going to be the same thing that we have on the bottom, except we change the sign in front of the weird thing. And I'm saying weird thing here because this could be a different kind of weird thing, and we'll see the same process with different weird things. So it's exactly the same, except you change the sign in front of the weird thing. So that negative in front of the x squared is a positive in the conjugate. And so we don't change our problem. We have to multiply by 1. So our conjugate has to be divided by itself. Then we multiply all the pieces together to get our answer. And we just multiply the 5 by both pieces of the conjugate. And we multiply the 4 and the negative square root of x by both pieces of the conjugate in the bottom. And you'll see that where I've circled it in red that says equals 0, this works. This gets the weird thing out of the bottom because you always get these two terms that add up to 0. In this case, we have a positive 4 square roots of x and a negative 4 square roots of x, and that adds up to 0, so it's gone. And we're just left with things that don't have a square root in them when we're completely done, since the square root of x times the square root of x is x. And we have an example problem here of 2 over 3 plus the square root of x. And again, to make the conjugate, that 3 plus the square root of x is exactly the same, except the sign changes in front of the square root. And if this were written in the opposite way, so the square root came first, you would still change the sign in front of the square root, not in front of the 3. It's always the sign in front of the weird thing that changes. And again, we're just multiplying, doing all those arrows, of multiplication. The middle terms in the bottom, again, add up to 0. And we're left with something that has no square roots in the bottom of the fraction, which was our goal. And a note here at the bottom in red that's really important. If you are multiplying by a negative number, use parentheses. You can see I have a little dot there. It's really easy for that dot to meld into your negative sign or to be so small that you don't see it. And then it looks like you're subtracting instead of multiplying. So the smart move here is if you're ever multiplying something that's negative, just use parentheses. That's it. Thanks. Bye.